The objectives of this lesson is to understand the definition of a relation. A relation is a set of ordered pairs. Now, a relation can be represented in several ways. You can show a relation using ordered pairs. You can show a relation using a table of values. You can show a relation by mapping. You can also show a relation in the form of an equation. And then you could also show a relation by graphing. So for example, Sarah works as a cashier earning $10 an hour. So in this relation, we can say that the amount of her paycheck depends on the number of hours that she works. So these two relations here, for example, if Sarah works 15 hours a week, then she will earn $150 because recall it's $10 an hour, so 15 times 10, that's 150. If she worked 40 hours, multiply that times 10, that's going to give you 400. And you can just go on and on with this relation of how many hours that she put in versus her paycheck that she gets out. So this relation between these set of order pairs, input, output sort of thing, we can express that in order pairs, where the amount of hours that she put in would be your value for X, and then the paycheck will be the output, the money that she earns. So we can write that relation, for example, as 15, 150, 400, 400, and so on. But again, I just represented it here as an ordered pair. So relations, you can represent them in the form of ordered pairs. You can also represent relations in the form of a table of values, and it's still those same ordered pairs, but you just have them in a table. And again, it has your input, the number of hours that you put in, and the amount of money that she'll get out, her paycheck earnings. So the X values represent the number of hours worked. The Y values represents the amount of the paycheck, the output. We can also represent this same relation as an equation. So again, the amount of the paycheck will depend on how many hours that she puts in. So we can relate this as Y equals 10X. So since you get paid $10 an hour, X means however many hours she works that she puts in, and you multiply that times 10, and you will get your output of the paycheck. So we call Y the dependent variable because this value, the amount of paycheck, is going to depend on how many hours you put in. It's going to depend on X, what's put in. So in this relation, Y is your dependent variable. That's why it's the dependent variable. It depends on what X is. And X would be your independent variable. And you will get to know more about independent and dependent variables as you go on in the statistics section of the course. Here's another relation. Same type, Sarah earns the $10 an hour. Notice that this graph is moving from left to right in an upward motion, which means this is a positive type of correlation, meaning the more hours that she puts in, the more money she earns. Notice that the x-axis is the number of hours worked, so the more you go up in terms of your hours, your paycheck is also going to go up. The y-axis represents the amount of paycheck. So again, we have represented that relation of Sarah earning $10 as a cashier in the form of a graph. Now let's talk about functions and mapping. A function is a set of ordered pairs in which each element of the x value is paired with exactly one y value. That's the math definition of it. To put it in plain English, where you can understand it, is just simply you cannot have two or more of the same x values. Your y values can repeat themselves, but not your x values. So just look at it that way. You'll see what I mean. Let's do an example. Here we have a mapping, and it's called a mapping. Mapping is used to represent the relationship between elements of the domain with the range. So here is our mapping, and what we want to know is, well, our x values here represents our domain or our gas stations, and the price per gallon, it represents our range or our y values. So what we want to know is, does each gas station, our x values, do they correspond with exactly one of the y value in price? In other words, we're going to look at these ordered pairs. So if we were to take these and write them as ordered pairs in parentheses, it's going to look like so. So notice we want to first direct our attention as to whether it's a function or not. Just look at your x values. If you notice that your x value repeat at any point, then no, it's not a function. It's fine for the y values to repeat, but not x. So here we see that for the x values, we have Valero, Shell, Texaco, and Citgo. So none of them repeated themselves. None of the gas stations were the same. So automatically, yes, it is a function. Now, if you look at your y values, 319, 329, 335, and 329 again, notice that the y values repeated themselves, and that's fine. You just can't have two of the same x value, otherwise it is not a function. But this relation here is a function, because notice none of our x values repeat themselves. In this example, we're asked to determine whether the mapping relation represents a function. So recall that a function is a set of ordered pairs in which each element of the x value is paired with exactly one y values. So first of all, we want to basically remember the quick definition of it is that you can't have two or more of the same x value. So let's put that to test. Let's look at our ordered pairs. So recall before we begin that your x values are your domain and your y values are your range. Let's go ahead and put them as an ordered pair. So first we have -3, 2. That's one set of ordered pair. We also have -3, -8. So I don't need to go any further in determining whether this is a function or not, because I've noticed I had, for the first two set of ordered pairs, I had -3, 2, and then -3, -8. So it violated that definition of a function because each value of x is paired with only one y value. Here, -3 was paired with 2, and -3, my x values, was also paired with -8. It was not paired with two different unique y values, so it is not a function. Let's go ahead and write it as an ordered pair, and that way you can visualize it. So here it is as an ordered pair. And notice that in that ordered pair, we have two of the same x values. So again, therefore, it is not a function. Here we're asked to determine whether this relation represents a function. So recall that we can represent a relation in many different forms. A set of ordered pairs is another form in which you can represent a relation. Now, all we have to do is just determine whether this is or is not a function. Very easy to determine. All you have to do, remember, is to just make sure that none of your x values repeat themselves. So take a look at all of your x values. So would you say that this is a function? If you said no, that this is not a function, you are correct. And the reason for that, notice here that we had our zeros in the x place to repeat themselves. So therefore, this is not a function. To be a function, you can't have two or more of the same x values. Here is a relation in the form of a table of values, and we want to determine whether it is or is not a function. Again, very easy to determine. All we have to do is take a look at our x values. It has nothing to do with y values. It is perfectly fine that they are the same. You look at all the -1 and you may instantly want to say, oh no, that's not a function. But it actually is. Because if you look at your x's, they're all different. None repeat themselves. So therefore, this is a function. You can have the same y values, but you cannot have the same x values. And because none of the x values repeat themselves, because they're all different, this is a function.